Okay, welcome back. We're going to be doing two additional examples, solving second order differential equations using Laplace transforms. A reminder of the two formulas required for this topic. In fact, you may want to add those directly to your Laplace table as I have done here. Okay, so let's take a look at, this will be example 3. What we have is y double prime plus 3y prime is 3. The initial values are 1 and 2 respectively. So using these initial values and plugging into the formulas for the transform of y prime and y double prime, we have the following. The transform of y double prime, the transform of y prime. So again, that's the two formulas that I had here at the bottom of the transform table, but with numbers substituted here as given in the problem. So now, as you know, we start by taking the transform of all terms in the equation, just like this. We're going to now use our formula to replace this term with these 3 terms and this term with these 2 terms. We're going to have to bracket here because it is a binomial preceded by this coefficient. The transform of the number 3 will be 3 over s using number 1 from our transform table. Okay, and we get this. So again, 3 terms replacing here, 2 terms replacing here, transform of the number 3. In the next step, I'll open up this bracket like this. We're trying to isolate L at y. This means I will be bringing this term to the right side where it will be added, so plus s. This is negative 5, but on the right side it will be positive 5. The only 2 terms staying on the left will be these 2, from which we can common factor L at y. And that will look like this. So s squared plus 3s in a bracket, all of these terms on the right. So next we'll divide this right side by this binomial. And at this point in time, what we can do is remove s as common here in the denominator first, and then since we have this fraction within our numerator, I multiplied the top of the equation by s and also the bottom of the equation by s. So you can see in the bottom it went from s to s squared, and in the top we have to multiply all 3 terms by s to get this form. Okay, now this form is not to be found in your table. What you're doing, of course, is looking for this particular denominator, and you will not find s squared in front of an s plus a term in your table. So of course, as you know, this means we're going to use partial fractions. We're going to treat this as a linear repeated term, so it will require 2 fractions, and then we have 1 more linear term. Okay, so here is our left side, and as I said, we're going to need 3 fractions in total, a denominator of both s and s squared to handle this repeated linear factor, and here a denominator of s plus 3. These are all now treated like linear factors with a, b, and c on top. Okay, in coming up with the next big equation, remember, this will be our left side. And on the right, A has S under it already. So in comparing here, it needs to be multiplied by 1 more S and by S plus 3. On to B. Plus sign in between, of course. B has S squared under it already. So again, in comparing with this denominator, it is only missing S plus 3. On to the plus sign, and then C has S plus 3 under it already. It requires only S squared. Now, we're going to substitute the roots. The two roots we can use are 0 and -3. So let's begin by substituting 0. When you substitute 0 on this left side, you will get 3. And on the right side, the only non-zero term will be here. So we will have B times 3. Dividing, we get B is 1. Next, we substitute -3. When we substitute on the left, -3, we will get 9 minus 15 plus 3, which will give us -3. The only non-zero term on the right will be here. C times the square of -3 gives you C times 9, from which C is -3 divided by 9, or -1/3. We have now run out of roots, so I decided to use the coefficient of S squared. Remember, the highest power is usually advisable. So if we look at the left side, the coefficient of S squared on the left side is 1. On the right side, where will we have squares? Here, and of course here. So I came up with this equation. So we're solving for the coefficient of S squared. We have 1S squared on the left equal to AS squared plus CS squared. And since we know the value of C is -1/3, we can substitute it. And A is found then by adding 1 plus 1/3 to get 4/3. These three values now are substituted here, here, and here. So this is what it looks like when you substitute A, B, and C into the numerators. The left side here is L at Y. We transform using 1, 2, and 3 from our table respectively. Each of those requires just a 1 up top. So that means 4/3, 1, and -1/3 will be the coefficients in our final answer. Final answer will be Y is, the transform here will be 4/3. The transform here is T, and the transform of the last one, 1 over S plus 3, e to the -3t. Okay, we're gonna do one more that also will require partial fractions. So this is our 4th example overall, the second in this video. Here's the original equation with the original initial values. First thing I'm going to do is use these values, which are both 2, they're both equal to 2, in these formulas. So we will have a 2 here, a 2 here, and a 2 here, in other words. And this is what we get, therefore, for the transform of both y prime and y double prime. We'll begin by taking the transform of all of these terms in the original equation, and that will look like this. The transform of t is handled with number 2 in the table. If it's t to the 1, it should have 1 under it, and the transform will be 1 over s squared. Here, we'll substitute these 3 terms, and after the coefficient of 4 here, we will substitute these 2 terms. And that gives me this. So here's the right side, the transformation of t, these 3 terms replacing L at y double prime, the 2 terms replacing L at y prime. They have to be bracketed since there's a coefficient of 4 in front of them. Next, open the bracket like this. So this will have a 4 coefficient, and here the number is -8. These 3 terms, 1, 2, 3, remain on the left, while to the right side will go this term as well as these terms. So this will be plus 2s on the right. Here we will have plus 10 on the right. Okay, plus 2s plus 10. Again, 1, 2, 3 terms on the left, from which I've common factored L at y. Now, isolate L at y using division. So here's the numerator divided by the trinomial. Let's clear out the fraction in the numerator. So multiplication by s squared of all 3 terms in the numerator. If we multiply the numerator by s squared, the denominator is also multiplied by s squared. This trinomial is factorable. Product of 3, sum of 4. Those numbers are 3 and 1. So the factors here are s plus 3, s plus 1. Like that. And now it's partial fractions time. We'll put this on the left. On the right, we'll need 2 fractions to establish the s squared factor, and then 2 more fractions for these last terms. All will be treated linear. Okay? So a over s, b over s squared, c over s plus 3, d over s plus 1. Making our big equation, this will be the left side. What will a be multiplied by? Well, it only has s under it, so it requires 1s as well as the other 2 linear factors. B has s squared under it already, so it will only require these 2 factors. C has s plus 3 under it, so it will need s squared and s plus 1 attached to it. D has s plus 1 under it, so it will need s squared and s plus 3 attached to it. So here is the equation. There are 3 roots, so I will substitute them one at a time. S, -3, and -1. S equals 0. On the left, we'll get 1. On the right, the only non-zero term will be here. B times 3 times 1, from which B is a third. Substituting -3 throughout on the left side will give you 37. The only non-zero term will be here. It will be C times 9. 9 is the square of -3 times -2. Like this, from which C becomes 37 divided by -18. Substitution of -1 on the left, you'll find the answer to be 9. On the right, the only non-zero term will be here. We will have d times 1. 1 is the square of -1 times 2, like this, from which d is 9/2. Lastly, let's go to the highest power, which is s cubed, and look at coefficients of s cubed. On the left, we will have 2s cubed. On the right, there is a cube here, so we will have a times s cubed. There is a cube here, c times s cubed, and one here, d times s cubed. So we get the following. 2s cubed is as cubed plus cs cubed plus ds cubed. Now, luckily we know c is -37/18 and d is 9/2. So after crossing out the s cubes and substituting c and d, we have this equation. So we can find a by taking 2, adding 37/18, and subtracting 9/2, from which you will get a is -4/9. Okay, we're really close now. We'll take these values, pop them into these numerators right here, and then do the transform. Okay, so here are our values of A, B, C, and D respectively. The transform numbers are 1, 2, and 3, and 3. Y equals, here comes our function of t. The transform of -4/9 over s is -4/9. Here, the transform of 1 over s squared is t. So we have 1/3 t. -37/18 and positive 9/2 will be coefficients here. The transforms will be e to the -3t and e to the -t. Okay, thanks a lot for watching. And I hope you'll try these suggested homework problems now.